Hello and welcome to today's presentation of our work quantifying the relationships between everyday objects and emotional states through deep learning-based image analysis using smartphones. Today's short presentation will have two parts. In the first part, I'll be talking about the background of our work and also the methodology that we used in our study. And then in the second part, I will be introducing the results that we obtained and also discussing their implications. So to get started, I'd like to give you a bit of background and then discuss our methodology. Essentially, in the past few years, we've seen quite a few works that link emotions on the one hand and various smartphone and sensor measurements on the other. This has included data such as location and mobility patterns, smartphone interaction data, and social media data. What we do in this work is that we instead propose to use another modality, which is visual information from everyday scenes. And specifically, we looked at the objects that appeared in these scenes. And the main question that we're trying to answer in this work is, are everyday objects linked to emotions? In terms of the methodology of our study, essentially we've had participants submit ESM mood reports together with pictures of their surroundings. In these reports, we asked them to tell us their levels of tense arousal, energetic arousal, and balance on 7-point Likert scales. And in the questionnaires themselves, we used the more commonplace terms stress, activeness, and happiness. Then we applied deep learning-based object detection methods to extract the objects that appear in these photos automatically. And then finally, we analyzed the associations between emotional states and objects that appear in these pictures that they submitted. Now, there wasn't a data set that already existed which allowed us to test these hypotheses. So what we did is we developed an Android app for the purpose of this study. This app was used by participants to record ESM reports, and we've asked them to submit 4 of these a day. And with the photos that they took for these reports, we also asked them to tap the photos to indicate objects that they feel are relevant to their emotional states. We've had 22 participants and around 3,000 mood reports over a minimum duration of 1 week. And the study ran from September 2018 to October 2019. And we also added some additional features in the app to encourage participation, such as being able to view mood statistics, a gallery of photos that people have submitted, and also something called a mood map. So essentially, participants were able to view their emotions at different locations during the study. So to summarize this work in sort of one picture, essentially users submitted photos using this MyMood app together with reports of their emotional states. Then we took all these photos and we fed them through an object detection method based on deep learning. And then finally, we analyzed the relationships between these objects and then the emotional states to figure out relationships that hold across all the participants. Okay. In terms of results, I will have to be quite brief, but you're more than welcome to check out the paper in case you would like more details. Essentially, in terms of the frequency of objects that we saw appear in these photos, we noticed that they follow a power law distribution with a very long tail. So that is to say there are many objects that appear very rarely, while a few objects appear very frequently. And additionally, we found that indoor objects are much more common in these reports. So for example, computer keyboard and laptop were the most frequent object classes that appeared in these reports. In terms of the associations between objects and mood, we found, for example, that in this leftmost column, work-related objects associated with increased levels of stress, while home objects that you would expect appear in a home associated with decreased levels of stress. In terms of activeness, we also saw different correlations between objects that you would appear to find indoors, such as bed and furniture, while for outdoor objects, they themselves correlate increased levels of activeness. We also found that relationships with valence or happiness were quite a bit weaker, so it's more difficult to associate this with visual objects in the external environment. And finally, we also found that these associations become stronger when location is taken into account. So for example, a computer might be associated with increased levels of stress when the user is at work, but we found that it is typically associated with decreased levels of stress when the user is at home, suggesting they might be engaging in leisure activities, such as playing computer games. In terms of the implications of this work, we've essentially presented another modality that can be used for mood-aware intelligent applications. We think that the findings of this study are relevant to computational psychology studies and also more broadly to architecture for the design of indoor and outdoor spaces for human use. And in terms of future work, while in this study we considered the collection of photos that represent the visual environments using smartphones, it would be much easier to gather this data using unobtrusive devices such as smart glasses and IoT cameras. Okay, that is the end of my presentation. So my contact details are there in case you would like to reach out with questions. I'll be happy to answer. And I would also like to thank my collaborators, Laura, Abhinav, and Mirco, and obviously yourselves for your attention. Thank you very much.